Okay, we have about 60 minutes together. I know it's after lunch, therefore I have to keep you awake. So I've been hacking on things for the last couple hours. I think I made something work. But I got a lot of cool things to show you in this session. So hopefully people here are Java developers primarily, and you're interested in how to make Java run more awesomely in let's say, the cloud environment. Okay? So we're going to show you some examples of what it means to build a Quarkus-based application, and at the same time we're going to show you a bunch of cool stuff related to Kubernetes also. For instance, I have Knative running here, which is the serverless architecture that sits on top of Kubernetes. So we'll see a little bit of that. Because the reason you want this lightweight kind of architecture is in a serverless context. It really makes a lot of sense. Okay? So in other words, when you want to go serverless, you want to go lighter, as light as you possibly can, because if it's heavy, it takes a long time to start. That's really the big thing in a serverless architecture is cold start latency is a killer, because your first user in has to wait for the whole thing to boot up to then get their request fulfilled. The next person in probably hits a live thing, right? But after so many seconds, it dies again, it goes back to sleep, and then the next person in has to wait. So if you think about that for a second, a serverless architecture makes a big difference. Okay, let me see if I can show you this though. This is the demonstration I was trying to make work earlier. So you guys can help me with this. Actually, go to this URL, bit.ly hybrid cloud 3, and bring this up on your phone. Let me see if I can make this work. Okay, I want to see if I can make this work, because it wanted to be fickle, but it's a particularly interesting demonstration of what it means to actually build an application and sprinkle it across the hybrid cloud. So if I just put in a simple message here and hit send request, I was in Sweden last time I think I did this, so it says allo. Right, so there's someone else to put in a 2. You put in whatever message you want, and then you'll notice that the response is coming from AWS. All right, so if you go to bit.ly hybrid cloud 3, you put in a message, there's a bunch of them now. You can see those are all coming from AWS. So let's do this. Let's go to AWS, and let's shut off its responder. Okay, that's the worker that's running here across on the message backplane. And now, test. If I put in test, you notice Burr is responding. So even to your phone right now, you're getting a response. You're going from Amazon to this machine right here to back to you to get a response. Okay? So that's Burr. And let me see if I can do this. Now this is where it gets a little bit tricky because I broke a few things along the way here. OC edit. So let's try this. kubectl edit DC. Oh, let me do this. Get DC. You guys can keep pumping messages in. Edit. See vertex messaging worker. Let's see if this will work for me. No, vertex, did I misspelled it? Helps if you spell things correctly. Okay, replicas 0. I'm going to scale it all the way down. Now if you put in something, can you spell something? Notice you're on Google now. So you just failed over from Amazon to my machine back out to Google. All right, so you're getting a response now from GCP. If I go kill the GCP one, you'll be failing over to Azure. If I bring them back online, you're basically now working with that infrastructure again. So this concept is actually fairly powerful. And it's what you can do once you basically have Kubernetes everywhere, right? Now you can take your applications and deploy them anywhere. And that's kind of the point of this particular demonstration. And this uses that Cupid dispatch router technology I was talking about earlier. Now in this case, it uses a Vertex application. I've not yet Quarkused this application. But I'm working on that, okay? But this is a Vertex app you're seeing here live. And you can kind of see also at the bottom here, it says Azure and Google, the only two left online, the only two processors left online. And it might be, let's see if my user interface is working here. All right, good. So as your transactions flow through, you'll see this chart update. And then, and actually, let me turn that off. So just at the request. And then if I want, I can crank up the volume. Let's actually go over here I'm just going to go to Amazon and crank up a burst of load. So we have a workload generator. And if you watch what happens, it'll go from Amazon through my machine out to Google. Right? So from Amazon to Google and Azure. Because my machine is turned off right now. If I turn my machine back on, let's go back in here. And replicas 1. And close. And it'll take a second for my machine to come online. So in other words, my processor will come online, we'll start processing people's transactions again, and you can kind of see what's happened there. So it reload balances and redistributes transactions based on who's available. So it's an interesting demo, so I just wanted to show that to you because I had to fight with it while we were at break. All right, and so you can see some GCP load there too. Okay, was that cool? But that's not what we're here to talk about now. We're here to talk about programming in Java. No, not that chart. Programming in Java, which is this guy over here. All right, so let's go ahead and start in the Quarkus land. The Supersonic Subatomic Java came to me after I watched the movie called Bohemian Rhapsody. And there's a great song, Can't Stop Me Now by Queen. Have you guys heard it? You know what I mean? Make a supersonic man out of you, make a supersonic woman out of you. So the tagline I actually came up with. That's my major contribution to the Quarkus effort so far. Okay? All right, so here we go. Now, if you come from the Java community, you've been talking about Java being dead for a long time. We've been talking about that for a really long time. So you like my Mark Twain Duke here? Okay? So we actually went back in 2006. I found this reference where they actually were talking about Java being dead 13 years ago. It is kind of amazing how long we've been talking about Java being dead. Yet Java is still #1 on the TIOBE index. It's in the top 3 for RedMonk. It's in the top 2 for HackerRank. Java is doing incredibly well. Because this is a key point. When we first launched this project just a few weeks ago, I had people debate with me online and in person, why in the world would Red Hat invest anything in something as dead as Java? They were shocked. They were shocked that they were appalled and shocked that we would invest at all in the Java world at all. Yet what we find in the Red Hat community, especially if you look at our OpenShift customers or our Linux customers, right? So Kubernetes, Linux, et cetera, as well as all the JBoss technology, the majority of our customers are Java. The majority of big banks, big insurance, big government, big healthcare, they're still running Java. Okay? So we know that Java is still doing relatively well. There's still a lot of goodness in this ecosystem. There's a huge ecosystem of frameworks and technologies and tools. So if you find your favorite utility, your favorite framework, your favorite tool, it is in the Java ecosystem. And that is why we still love Java and why it's continued to do so well. The challenge is this is a lot to carry. This is a lot to consume. So Java has put on a little bit of weight over the years. And so it's actually not Java the programming language, nor is it Java the JVM. It's actually the frameworks that we've added to it, like Spring and Hibernate and Camel and this and that and whatever. All those things are what cause the load and bloat to the Java application. So, he keeps putting on weight. And this actually was not a big deal, okay? Because we could just keep throwing hardware at it. And that's what we did for Java people. We're like, another CPU, fine. Another 2 gigs of RAM, fine. We were good until we put them in a container. Because in a container, you don't think like that anymore. You think that resources are scarce, not abundant. You see the difference, right? In the old world, we're like, we bought that $100,000 server. Let's just use it. In the new world, you're like, I'm paying $50 a month for that server. It's a very different mindset, right? And somebody goes, can't you make it $40 a month? Well, I could if the thing wasn't so fat. I could shrink it down. So when you put things in a container, you start to notice. And you particularly notice when you lock it down. So in a Linux container architecture, and this is, by the way, not Docker, not Kubernetes specific, this is Linux kernel stuff here. It's called C groups is the technology. And when you lock down a Linux process with memory constraint or CPU constraint, actually Java blows up, okay? Because by default, Java being born back in 1996, 1999 was app servers, it knew that it owned the hardware back then. It does not own the hardware any longer. In other words, Java sees the whole hardware's CPUs and memories. It doesn't see the constrained version. Now, this has been fixed. I've been complaining about this so loudly with the OpenJDK team. They just fixed it like in the last couple days. So maybe I can show you that. But by default, if you put Java 8 in a container, it blows up. So if you've done that and you notice that your Java JVM seems to be rebooting a lot, restarting a lot, you're like, now you know why. Because the good news is with Kubernetes, it just restarts automatically. You don't know why it blew up, but it came back to life. It ran out of memory is what the problem is, because it tried to grab all the memory on the hardware, right? Not just what's in the container. So this was never a problem until you get into container land and you start thinking in this kind of terms. How do I scale out and run a lot of things? And so these quotes are really phenomenal. This is a publication on Reddit that I found. So, hey, how do I use Spring Boot in Java for Amazon Lambda? The responses are, why would you ever do that with Amazon Lambda? Java's too fat and slow. All right? In Amazon Lambda land, memory is not abundant like the Java people think. Memory is very limited. As a matter of fact, memory is our most scarce resource. The problem with Java is startup time. You can't wait. Your users can't wait for that cold start latency. So these were some things that really informed our decision making and our thought process as it went into designing Quarkus for this new world. Okay? So this is Quarkus Supersonic Java. My wife had a lot of fun with this design, by the way. All right? So what's all the fuss? The concept here is very straightforward. By default, we found ways to make the pure JVM mode of your application architecture about 10 times smaller faster. All right, depends on what you do, obviously, but a ton faster than where you are today, a ton smaller than where you are today, and it compiles down to native. So now you're more in that level of Go level of competitiveness now. So if you're an organization, which I've met several, who are like, we're rewriting our microservices in Node.js, I'll show you in a second, we're smaller than Node.js as Java, as a Java-based thing. Now, that should be mind-blowing if you've been around the Java world for a while. Now, it's not as small as Go, except in certain use cases, it actually gets as small as Go. But Go, Go's pretty tight. So you're now in that world where you might be thinking, well, Java as a programming language might be okay in this new world. Okay? So we're going to show you that. Now, the one thing I really want to spend some time on, though, is how, from a developer standpoint, we focused really heavily on the developer experience and what it means to be a developer in this new world. Okay, so you have this concept of live reload, which I'll show you a lot. You have the ability to marry imperative and reactive programming models. I do a lot of Vertex stuff, and I've done a lot of Spring Boot stuff. Now the two worlds have come together, if you will. Serverless architecture, if you need to go serverless, you can now. Right? Microservices, certainly. Fat jars, as well as native executables. So you can have a traditional fat jar, if you will, like the traditional JVM mode of running an app, or you can actually compile it to a native executable. I've been thinking about putting .exe on the back of those things just for fun. But in Linux, you don't do that, so I'm kind of an old Windows guy. All right? But this is a Kubernetes native architecture. That's what we've been focused on, to run in this highly containerized, highly virtualized world. So there's Duke on our bike there. This is, again, I showed you this in the earlier presentation. This is kind of the journey we've been on in this world. So you can kind of see Java was born back here in 1996, well before there was a Red Hat Enterprise Linux, before there were Linux containers, before the world cared about virtualization, before there was a cloud, okay? Before all those things. And Java assumed it owned the hardware. That was really that was just part of its ethos, right? We own the hardware. You buy $100,000 worth of server hardware, we own it. In this new world, it doesn't. It owns a sliver of the memory, a sliver of the CPUs. And that's kind of the thing that had to change. All right, this is the history of Linux containers. By the way, the link to the slide deck is down here at bit.ly Philly Quarkus if you need it. And this is actually a history of serverless architecture. So we've been actually thinking about serverless now since 2011, 2012, back when Iron.io and Firebase were out there, basically database in the sky, message broker in the sky. And of course, Amazon Lambda was born in 2014. But now everybody's doing some form of serverless in this world. And the one we're basically working with right now is this thing called Knative on top of Kubernetes, which gives you serverless behaviors on top of Kubernetes. Okay? Now, this is one slide here that we'll go into some detail on, but we're actually going to show you this, right? So if you look at a basic REST application, get, put, post, and delete, 13 megs of RAM versus 140 megs of RAM. Okay, so a 10x improvement in memory. And that's RSS memory, so just keep that in mind, right? So this is not heap. A lot of people confuse this with heap, and that's not what you should be thinking about. The JVM by itself sucks up a ton of memory. Okay, and then you have heap, your memory on top of that, your data memory on top of that. So this is total memory from that perspective. Also with a CRUD-based application, I'll show you an example of this. 35 megs of RAM versus 200 megs of RAM. Okay, and then of course startup time. You're looking at basically sub-second startup time, sub-half second, sub-hundredth of a second in some cases startup times versus 8-second startup times, 20-second startup times. And some of you might be thinking, wow, an 8-second startup time would be awesome. That's still too slow. Your user has to wait 8 seconds. In addition to all the infrastructure to ramp up, they have to wait 8 seconds for your JVM to start up, all right, in a serverless architecture. So that's what you don't want. Okay? So focus on the boot time to first response. That's really been the core benchmark we focus on. This is not lazy loading. This is not the, we load the JVM, but we don't load it in the framework architecture. This is the whole full stack loaded, right? The time to first response is what matters in this cold start latency world that we're dealing with. And this is based on this technology called GraalVM, GraalVM and Substrate VM. This is technology that you see out there that's open source from Oracle. When you're working with Quarkus, we tell you to download it, and therefore you can compile to native. If you don't download it, you can't compile to native, but you can still use it as a fast JVM-based solution, fast and small JVM-based solution, or you can compile it to native code. Okay? Now, a couple things on Kubernetes. The reason this matters is because Kubernetes, as I mentioned earlier in the earlier presentation, you have the scheduler, you have this API, you have this etcd. You basically say, Kubernetes, deploy my thing. I want 2 of these, 5 of these. Actually, you just saw me make a change, right? I just sat there and declaratively changed the layout of my application, what I showed you earlier. You basically ask Kubernetes to make a change. Kubernetes finds a node out there to run your thing, whatever your thing is, Tomcat, SQL Server, Wildfly, Spring Boot, Node.js. It doesn't really matter what it is. Right? Kubernetes finds a place to put your workload. And in this case, you can see we have replicas number 2 here. Okay, so I got to have 2 replicas of this thing, whatever this thing is, and I got to place it out here. So you can kind of see there's my 2 Tomcats showing up right there. So I have 2 Tomcats sprinkled across my cluster. You can also be very smart about it. You can basically have anti-affinity rules. So basically you can say it has to be on 2 separate nodes, maybe 2 separate racks or something like that, because if that node goes down, I want to keep the other one up from an HA standpoint. Okay, and then you can also look what happens here. If this guy dies, Kubernetes is always watching. Right? So not only is it making sure that initially you get the 2 you want, it's always watching and says, oh, that node or that pod died for some reason, and it could be due to the JVM out-of-memory error that I mentioned earlier. JVM does blow up, and it just moves it. It doesn't really move it, it just respawns it someplace else. Okay, so Kubernetes is always watching. So therefore, this startup time and how fast it moves around this cluster of nodes matters. You will see a performance impact if you have huge images, huge startup time, fat memory. Right? Because it's trying to load balance across this cluster of servers. Now, what if I want 20 of these? Okay? Now, if I need 20 to handle my load, well, in the case of a Quarkus-based app, you can pack those in with greater density. Okay? So this is just the beginning. Let's get started here. That is the quick and dirty slideware intro. Again, the slides are at bit.ly Philly Quarkus down there. So that link will get you to the slide deck. But I want to show you this thing in action. Let's see if we can make it run. Let's see here. Let's not worry about that anymore. And yeah, okay, we don't need to worry about that one. Let's come over here. Okay. All right, so let's do this. Let's make a new project. Let's call this one Philly. Is that fair? So I'm going to make a directory. I'm going to cd into that directory. Okay, now what do I do next? All right, I have an empty directory. There's nothing in here. Right? So we got to do something now. The nice thing is, on the website, it tells you, it has all this great getting started content. So if I look here, the first thing you can do is basically run this Maven command, and you just have to have Maven installed on your machine. So if I look over here, I have Maven version. Let me see if I typed version incorrectly. No, it's probably -v, I bet. I always get these things wrong, but you can see I have Maven there, and I have Java 1.8. So that's what's on my machine. And now I can run this create command. I don't want to copy that one, copy this one. Run that create command, and it's just going to prompt me for the things that I need to do to kind of get things set up here. So let me move this up a little bit so you can see it. So com.burr Sutter, Philly. I've never run this demo before, so you guys are special. You guys are the first time to see this thing. Okay, all right, so 1.0, and I want an endpoint. Yep, that's fine, that's fine. All right, so it's now given me a little bit of code. Okay, it's dropped in a little bit of code into my project here. You can see there's a Java file that is the hello world endpoint, an application properties, an index file, okay, and there's some other goodies in there, but let's go ahead and open up our programming editor. I use this thing called VS Code now as my primary programming editor. You might ask why. It's because I've always been a lightweight editor person. I've never been a heavyweight IDE person, ever. It's just something I've never really gotten used to. And let's see here. I'm going to, if I can find it. There we go. Red Hat actually did the Java support for Visual Studio Code. So we have 15 million downloads of Java integrated in Visual Studio Code. So that my team worked on that at Red Hat. So I liked Visual Studio Code before we did that, but I was just going to make that point. Now let me go in here into this little endpoint we saw earlier. Let's make this a little bit bigger. All right. So there's hello. OK. So I have my application initially, but now we need to kind of do something with it. I'm going to come in here and open up a terminal. And we're going to do Maven Compile Quarkus dev. So that command basically says, start me up in developer live reload mode. Okay, this is not production mode. This is live reload mode. So this means I can now edit the code and make changes to the code and interact with it. So let me go over to my browser. Okay. See, it says hello right now. So localhost 8080. I guess that's hard to see right there. See that? Hello. And it returns hello. No big thing there. Okay, let's come back over here, and let me do this. Ooh, that's going to be too small, but let's move this over here a little bit. Okay, now I can say, I want to say aloha. Right, I'm originally from Hawaii, I want to say aloha. All right, cool, there's says aloha now. So basically you just edit, save, refresh, right? So this might not be a big win for you. If you knew how to use your Java debugger, you could kind of get the same kind of feature. But let's go a little further with it, all right? Let's kind of have a little fun with it now. So I have the aloha. What do I want to do next? And let me see if I remember this correctly. Oh, and notice there's also a main page. If I go here to the index, all right, you can kind of see there's a main page under source main resources, resources index HTML. So that is that page here. That's, again, part of the generated code you get for free. I can come over here and look at it. All right, I'm not going to mess with that for now, but you can edit, save JavaScript, CSS, HTML, Java, as well as the application properties file. But let's add some, let's actually show you the testing. There's also test built into this if you are a tester, and you should be if you're not. So I can come in here and look at the test. So I can say run test here. So it's running my test now from the IDE. And of course I changed that to aloha. It's no longer hello. Therefore I get a little red X there. I can click on the X and it'll say, dun, 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 dun. All right, actual is aloha when you said it was hello. So let me go ahead and fix that real quick. And what I'll do is I'll just fix the test because it should have said aloha to begin with. Don't you guys agree? All right, fix that, run the test again. Okay, so I can do the interactive testing that you might have if you're living that test first kind of world or even test after kind of world like I did here. Let's ignore that for now. We'll come back to that if we need to. I'm more interested in kind of doing a real application. All right, Hello World is easy. Everybody knows Hello World is easy, so let's kind of do something for real now. Let's go here. I'm going to go into the terminal down here, and I'm going to make this a little bit bigger, and I'm going to run this command, Maven, Quarkus, list extensions. So out of the box, we actually have a bunch of extensions. These are frameworks that we've gone in and optimized to be smaller and faster. Okay? Smaller and faster on the JVM and compile down to native. Because Java by itself is awesome, but it doesn't give you a lot to work with when it comes to, let's say, connecting to a relational database. And that's what I want to do next. The average person actually connects to a database, so let's try to do that. So we're going to come in here and look at this screen. Let me make it a little bit smaller so I can read it a little bit better. Okay, so let's do this. And what you'll notice is at the bottom here, it'll say you got to run this command, add these extensions. So I'm going to copy and paste this right here. And I'm doing all this from scratch, so you guys would do the same thing. And what do I want? I want to get the Quarkus REST Easy JSON-B because I'm going to do a serialization to JSON in my application. So let me grab that one and paste that in here, comma. Let me also get a Hibernate Panache. We're going to see Hibernate Panache in action. Hopefully you guys know about Hibernate. This is a new thing we've been working on. If you're familiar with Ruby on Rails Active Record, or maybe the Play framework with Scala and Play, you've seen something like this before. You'll see it here, something new we've done for making Hibernate easier to work with, because the Hibernate team works with us at Red Hat. And I think I got them all right there. So I'm going to have PostgreSQL, and I'm going to have Postgres, JSON-B, and Hibernate, right, basically. So yes, I want to reload the POM XML, move this down here, go down, there we go. And let's go look at the POM XML, and you'll see that I added those three components to the system. So there's JSON-B, PostgreSQL, and Panache, right there. All right, so I have my dependencies in place. That's all cool. I can come over here and do a Maven Compile. Let's bring up the live reload again. Compile the Quarkus dev. All right, let's get back into live reload mode. And now we have some fun with it. So let's ignore the test for now, ignore the resources for now. Okay, so now we're set up to build a database application. So that's where I want to kind of have some fun with this. So for a database application, if you're familiar with Java, the first thing you'll do is build a class which represents your entity. So I'll call this to-do. We'll make a little to-do application. I need to give it a package. So this is Burr, Sutter, Philly. Okay, and this is public class to-do. And all right, and now the next thing you do, right, if you're building a Hibernate style app, you say at entity, or for JPA persistence. And now you can basically just put in your attributes, right, like title, order, completed, which is what a to-do application has. And then you have your what? Does anyone know what you put in after you put in your attributes, your properties? Your getters and setters. You don't need getters and setters though at Panache, all right? So let's kind of show you that. So Panache makes some assumptions. So if you extend Panache entity, and then I can say public string, let's put a capital S on there, public string, and this is the title of the to-do, and hit save. That's all I have to do. I now have an entity. Okay? No getters and setters, and you could have getters and setters if you want to add additional, mutation properties, right? So on set, you can only have this certain set of, if then else statements or something like that, or on get mutated the other way. Most often, people say you should have anemic entities, right? And don't put a lot of business logic in them, but you could. You could do that here if you wanted. But now I need to connect to my database. All right? So here's where it does get a little bit hard. So I'm actually gonna cheat and copy and paste some of this here, just so you know. Okay, right. So right here I have the commands to connect to the database. And so it's the Quarkus data source URL. And you can kind of see let's call this my Philly. And my Philly, whoop, dun, 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 and my Philly. We'll just give that the same name everywhere, just to make it easy for me. All right, and copy and paste that. Okay, so that's going to localhost. That's the Postgres on my local machine, and it basically has the driver name, the user ID and password, drop and create by default, which is a hibernate thing, right? Basically it'll blow away the schema, reapply the schema based on changes, and log out the SQL true. Now, I do need to go to Postgres and come over here and make a database for this. So let's go into create a new login and group role. Let's call that my Philly. The password will be my Philly. I'll just go ahead and make them a super users to make this easy because they're going to have full manipulation of the database that it owns. It's just in development here for my getting started experience. Call this my Philly, map it to the my Philly user. And if I did all that correctly, okay, let me hit refresh here. Notice it reloaded. Let me go into my Philly, schemas, public, tables, to do, columns. We now have a table, all right? So there's the ID and title. I didn't have to specify ID. Hibernate gives you an ID by default, but it does have title with the guy I just created there. And so if I come back over here now and add to this, let's say I want title. I want a public Boolean completed. I want a public int order. Now, one thing I do know about the word order is one of those reserved words in the Postgres database. So let me actually kind of fix that real quick. Dun, 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 dun. And I'm going to basically say name equal ordering to kind of make sure we stay away from that issue. All right, come back over here to my browser, hit refresh. Okay, I'm not making really any code changes you can see visibly, but you do see it at the database level. So let's come over here. Refresh, there we go. And to do, and then columns, and there we go. There's all our columns we've added. Okay, so we kind of have a database schema now. Now let's go write some logic associated with that. Okay, so we have the basics of our database schema. So I'm going to now build a REST endpoint, new file, to do resource. You guys have to make sure I spell things correctly. Okay. And let's send it, looks good there, right? Okay, so package, Burr, Sutter, Philly, and public class to do resource. Okay, pretty good stuff there. All right, so this is a REST endpoint. So what does a REST endpoint need? It needs to know what path it's going to respond to. So at path, okay, so it's going to respond to /, just make it simple for myself. Notice the little light bulb there, VS Code saying, hey, you haven't imported this yet. Yep, good point, you need to import it. Now, I want to be a good backend service, or I want to consume JSON, not consumer type, consume, okay. Let's get rid of this one. Consume JSON, let's see here, there we go, consume. And when I say JSON, that's the media type application JSON right there. All right, fantastic. It also produces JSON. Okay, all right, so we're going to have JSON in, JSON out. Let me get that import sorted out. Nope, I don't want to do the static. I just want to do produces. And helps if you spell produces correctly. Okay, all right, good. Okay, now, so at get, so we're going to say public. And now I'm going to return a list of to-do. So list, to-do, get all. How about that? And dun, dun, return to do list all. So again, Panache is basically doing some clever things for me. It's giving me some helper methods to basically say return a list of all the to-dos we can find. So there are some specialty features like that. So all right, list all. Respond to root. Let's go over here and hit refresh. Okay, the problem is this web page is served first, the static web page. Let me delete this web page. And this guy right here. Wipe that guy out. Now it's gone. And we should have our empty array. Okay, it's an empty array. We don't have anything in our database, right? If I go back over here and look at my database, there's nothing in the database. So all rows, it should be empty. Yep, we have nothing in our database right now, so there's nothing to return. Let's have a little more fun with it, though. Okay, we're going to come in here now and basically add a post method. So at post. All right, so this is where it gets a little bit more interesting. So public response, and that's a JAX-RS response. And we're going to basically say add, and we're going to add a to-do. And so to-do item, and then we're going to basically, let's add that import. Yep, that one's the one we want. And let's do this. We're going to say to-do persist. And persist. Again, a simple thing to persist. And then we can return response. OK. And that should have been item, by the way. Item. OK, we're going to persist that item. Status. And in the case of a new addition, it's 201. And then build. There we go. All right. All right, so we're going to persist. Now, we just need to issue a post. And let's go ahead and let's go check this out. So we're still empty. And then here's the thing that's kind of tricky. I have a curl command that does a post. Let me see if I can go find it. There we go. This one right here. It just basically does the post with the right JSON payload. So if I run it, it looks like it works, right? It looks like it did a post. If I come over here and refresh, I get no data. And that is because I didn't use the transactional keyword, all right? If you want it to be transactional against the database, Quarkus actually does stand transactions out of the box. So you can basically say it's transactional. Now let me see if that post will work for me. I hit save, I hit refresh, and let's go over here. There's that record, okay? Now if I come back over to my table in my database world, let's go here, view all, and there's our first record. So now I can have the ability to add records to the database. So at this point, I have enough working that I can kind of bring over my user interface. So I have a nice team of designers. They built me a UI, and actually it's not true. This actually comes from To-Do MVC. If you guys have seen it before, it's a great little open source project that basically has To-Do written in all different client-side languages. And so I can come over here now and basically copy and paste it into my application. Dun, 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 our resources. So this is a Vue.js project. I'm not a Vue.js person, but I don't have to be now. I can hit go to the right place in the browser. Let's say to do HTML, and there it is. So 2, 3. OK, now we have 3 records in our database. And yep, 1, 2, 3 there. Fantastic. So we're cooking with gas now. All right, we have create and read. We don't have update and delete. Right? We got 2 of the CR, but not the U and the D. But we have a user interface, and this user interface does allow for all those properties. So let's kind of finish up a little bit more of these things before we kind of switch gears to a different thing. But let's see here if we can do this right. OK, so I got the post. Let me add a delete. And we want to delete. It needs to be transactional also. OK, now in this case, it has a slightly different path. We're going to have an ID that comes in, okay? So public response, delete, delete. And this one has the @path param with ID. And we're going to map that into a variable called ID. Talk about being original there, okay? And then we're going to say to-do entity equal to entity equal to to-do.find by ID. Look at that. So again, another one is convenience methods where Panache is basically saying, hey, we know you want to find it by ID. That should be pretty straightforward. Entity.delete. That should be straightforward too. And then we want to return a response, which is a status of, and that's 204. Build, okay. So I think we did that right. Let's find out. Save, come over here, and let's delete number 2. Okay, it looks like it went away. Let's check our database. And, you notice what happened there? Notice I'm doing this thing where I have to refresh on the table, and that is because every time I do a reload, it's automatically dropping the whole table and rebuilding it every time. I don't really want to do that right now. My table schema is okay. Let's just leave that alone for now. Let's do an update. Okay, so let's try that. And let's go back over here. And let's add 2 back in. Okay, now 2's back in. And let's go over here. Okay, so 2. All right, so 2 is the only one in the database. Let's see it refresh. Okay, that's right. So 3, 4. Okay, looks good. Now let's delete. Well, let's go check this real quick. Is 2, 3, and 4. And let's delete number 3. Let's see if that worked out for me, because we're testing delete. Yep, number 3 is gone. All right, so we got delete. Okay, so let's do update. Let's do update. Update's a little bit trickier. Not much, but a little bit. Okay, so I'm actually going to copy some of this, because a lot of this, this is about the same. And I want to say patch. All right, so patch is actually a special one. You might not have, you can think of it as put. Put is a complete replacement. Patch is fix the things you just want to fix. Okay, so that's why we're using this one called patch. I'm going to make it my update, though. That looks the same. That looks the same. The difference here is you're going to say entity dot, and you're going to patch it. So therefore, you're going to say, and I got to do this. I got to pass in to item, the original item that's coming in from JSON. So again, that JSON serialization is happening for me automatically. And I can say entity dot order equal to item dot order, and entity dot the title, right? We've got to have the title equal to item dot title. Okay, cool. If I did that correctly, and by the way, if I have a syntax error, like there, you can kind of see if I have a syntax error, you also get that information in the browser too, so you can go, oh, yeah, there's a semicolon missing. Cool. So, we try to make it as easy to use as possible so people can kind of work with it. And all right, so there we go, 3, 5, and let's try this. Learn Quarkus. Let's try the update. Hit return. Come over here and go see. Yep, learn Quarkus. Okay, cool. All right, so our updates are in place now. Love code. Love code. And come over here to the database, check that out, and love code. Fantastic. And also, is it completed or not? So love code, we'll do those completes right there, and hit refresh over here, and you can see completed equals true now, right there, right? So completed is true for those 2 I just checked off. So our user interface is working, most of our backend is working, it's got more capability than that. Let me do one more thing. Actually, let's add one more little thing to this while we have a few moments. I want to go back to drop and create. Actually, before we hit save, I want to show you why. So 2. Right now, it allows you to add the same thing again and again. That's really not right. You want those to be unique. So I'm going to come in here and say drop and create, and then I'm going to add another little rule to this. Not blank, column, unique, equal true. Okay. If I did that right, we hit refresh, we'll see everything gone. 1, because drop and create. 2. Notice this 2 is it's not allowing me to add 2, and you notice I'm getting exceptions over here. So I might want to have a different user interface to deal with the fact you can't add the multiples, but that's okay. 3, and so learn Quarkus. Looks like this is all working well. And everything else should be fine. Come over here, and of course that table got dropped. Hit refresh. And let's see here. Dun, dun, dun. Okay, what do you guys think of that? All right, so a real application, or not a simple hello world application, but a real application built using normal enterprise-y type behaviors, and then all that done with this nice little framework we call Hibernate Panache on top of Quarkus. And here's the cool thing about that. You can now say, okay, that's my app, if that's what I want it to be. I can Maven clean package that app. Let's Maven clean package that application. That'll produce the jar that you're used to having if you're dealing with a normal Spring Boot style application or a Vertex application or a Drop Wizard application. It all works the same way. You're going to get the large jar, if you will. Now, we actually have done something a little bit special here. Okay? If I go and look at target, see there's this Philly runner.jar. LSH target. It is 1.1 megabyte, because actually what we've done is we've actually multi-layered this. Knowing that you're going to put this in a container, okay, lib also has to go with your container. So you typically want your infrastructure logic at a different layer in your Docker layers than your application logic, because one changes faster than the other. Application logic should change faster than infrastructure, right? So your infrastructure is in lib, your application logic is in the Philly one right here. Okay, so just remember that you got to put 2 into your Docker container. One thing that's nice about that is we show you that when we do provide out-of-the-box Docker files. So if you come over here, you can kind of see, we tell you, here's how your Docker file should work. And you'll notice there's the copy lib right there, and then copy the runner. But we also have the ability to do a compile to native, okay? For the compile to native, though, I want to show you a different project. So there's, CRUD-based operations on the database. Let me show you this application. I call it Finger Paint. It's a little bit more fun. And let me see if I can get it up here. Okay. This is actually a slightly different application. It is my really bad JavaScript on the front end. And actually, let's run it real quick. Maven Compile, Quarkus, dev. Let's just bring it up. Okay. There we go. And come back over here, hit refresh. This is on the root. Okay, this one, I call it finger painting. You basically use your finger and paint, and then you have a back end to it called dashboard. And then this is WebSockets. All right, so this is the WebSocket capability. If you've been to one of my Vertex presentations, you've seen this before. I've actually migrated it from Vertex over to Quarkus. So not that guy, let that one be, but this one over here. So you can kind of see now, as I draw, pick colors. So I am obviously not a very good JavaScript programmer, but I can now see that that's my application. If you look at the back end of this application, it's very straightforward. It uses WebSockets, so at server endpoint, at application scoped. I call this thing WebSocket. You could call it whatever you want. It has a session counter. So basically, every person who connects is part of that session counter into that session map right there. And then what happens is it basically receives all of these strokes from the canvas and sends it out to all the waiting dashboards. Okay? So it's like a real-time chat application, but it's all Pictionary style. It's kind of a simple little app. Now, so you can kind of see how it works, but now let's go ahead and do our compilation of it. Okay? I have the build native Linux over here. I'm going to build the Linux native image of this. Okay? Let it run. Now, this actually takes a little bit of time. Okay? Because what happens, there's a lot going on when it comes to being compiled down to native. And I have some diagrams here. Hopefully, it'll help make some sense. Let's kind of come over here and check this out. Okay? So when we say compile down to native, there's actually a bunch of things that's already happened and will happen. So in other words, you notice that there was all these extensions that I showed you earlier for Postgres, for MySQL, for Hibernate this, and all that. Those are things we've gone in and pre-optimized for faster boot time on the JVM and ready to compile down to native. So there's pre-optimizations that have gone into the frameworks themselves. So that's an important thing to understand. You can bring any old framework, and it might work, but the ones we pre-optimized are going to, of course, work better. And we want you guys to bring your own frameworks, and there's a whole guide on the website on how to build these extensions. So, there's a bunch of these things out here already for basically how do you build your own extension. So keep that in mind, including how this magic works. Okay? So the other aspect of it is when we're going through the process, we actually are both interpreting the bytecode, generating code, filling in gaps that need to be filled in, and also it's doing an aggressive pruning of stuff you're not using. So this is an important thing to understand. There's this concept of ahead of time compilation, AOT, and it's basically pre-optimizing the entire stack so that your native binary that comes out the other end only includes the pieces of the framework you used, and more importantly, only the pieces of the JVM you used. Because the JVM, by default, if you ever looked at rt.jar on a JVM, it's massive. It has tons of things you never, ever use in there. Like, do you use the HTTP server that's built into standard Java SE? Most people don't. Do you know you can do web services and REST stuff in standard Java SE? Most people don't even know what's in there, right? There's all kinds of stuff in there, not just the swing and all the client-side GUI stuff that you never use in a server-side architecture. So you can basically prune all those things you don't need out and get down to a small native executable. And so this is, again, making this optimized for the Growl VM and Substrate VM optimization, and then using that to compile it down to an executable. Of course, you can kind of see what we've done here. Quarkus course, it's on these three primary libraries here. You hear this one called Gizmo when you read about it. Gendex for annotation processing. You got to keep in mind all those annotations in your code. Normally, the way annotation processing works in a Java-based app is it loads your classes from disk, it scans the bytecode for those annotations, it makes an interpretation of those annotations and decides what to do about them. That's what normally happens in a JVM. In this case, we pre-optimize that. We're not doing that at runtime, we're doing that at compile time. After all, the annotations were in there when you wrote the code. Why do it at runtime? We can do it at compile time, right? You see the difference? So the annotation scanning and all that stuff is happening before, not after. And so that's what's happening. And then, of course, these libraries sit on top, right, these extensions. And you, of course, get CDI, right? So you get dependency injection, you get REST, you get all the standard stuff you're used to. Narayana, by the way, is the transaction server. That's the transaction capability I had earlier. So you get a full transactional support. And let me go back over here. I'm curious to see. And it looks like we're done. So target. And this one right here is the Linux native binary. So let's see here. Dun, dun, dun. So I can't run it on the Mac. I could build for Mac, but I'm built for Linux because we're going to have a little fun with this. All right, so 17 megs. 17 megabytes is everything, the entire world for that little finger painting application. So if I come over here now, let's see here. I have a little tool. Yeah, I'm going to SCP it up to a server that you guys can touch. Okay, so it's moving up there now. 20% done, 24% done. Almost. Okay. SSH game.burr.red. Let me SSH into that server. Dun, 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 dun. All right. There it is. Let's see if it's going to make it up. It's up there now. And then I have a little run tool to help me run it. But let's see right there, it's up. And if I come over here now to, looks like I loaded this once already. Okay, so there it is. You notice I connected. You see the logging in the console too. Now you guys can connect. So you guys can go to game.burr.red, :8181. I have something else on 8080 on that machine. All right, you can go to that URL. And yeah, I see you connecting now. You can paint pictures for me. A lot of people are connecting. Okay, good. And yeah, let's go over here. And let me get this reconnected. And now we can paint pictures together. There we go. And then you notice each stroke that goes down, you guys are interacting with my machine. I can clear. I can put in my name. Yes. All right, there we go. So, and if you hit refresh, you get a new palette, a new canvas, so you can paint something else. Okay. It just starts a new session for you. All right, so there you go. You guys can actually paint pictures, but this is a simple example of what maybe a native application can do for you. You could do this with Vertex, you could do this with Spring Boot, but it's now just a simple little thing that I can just ship, okay? And if anybody does anything inappropriate, I can also come up here and put a little smiley face on it. Okay, all right, so we'll hit Control-C, and I just shut you down. I have another little game, by the way, out there. If you actually go back to, if you take off the 8181, we're not going to have time to play this game. This is a super fun game. It's my Fruit Ninja style game, you know. But unfortunately, we just don't have time today to play that game. So you guys can play this one. This is another thing we've been working on, so you can have a little fun with that one. But let's hit pause there. All right, game over. Now refresh. And go. Okay. Now, let's show you one little bit before we run out of time. Okay. Now, you've seen how we build a CRUD-based application for database access, seen how we build a little native application. Now let's put some of these things together to kind of hopefully make a little sense here. I have a Kubernetes running a different Kubernetes than the other one, right? The other one that was running the hybrid cloud demo. This is a different Kubernetes now, so I have 2 clusters running on this machine. And I have some pods running here. I have one called Postgres and one called Quarkus API CRUD. Okay, so this is where I'm running it now in Kubernetes, as opposed to outside Kubernetes that you saw me doing earlier. And so I can even do something like run a little poller here. There we go. And let me also, I have a script for opening the browser. So this is on my local machine. So I can come here and say Philly, hit save. And so I'm basically interacting with this database application now. All right, so that looks good. Now let me do this, minikube. This is -p, knative, SSH. Is it not called knative? Which one is it? It is K, what's that? Oh, it helps if you get the N in there, right? There we go. Okay, so PSAX-O, PID, RSS, command, grep, and this was API CRUD, I think I called it. All right, so there it is, 50 megabytes for that CRUD-based application. All right, so 50 meg Java-based application running as a native component. Just kind of keep your eye on that because we're going to have a little bit more fun with this. Let's do this. Let's go to my Node.js application, and I'm going to do this thing called KN burst. So here's, watch closely here. So if you see this pod count over here, this right here is going to add enough load to the system when I run it. It's going to add enough load to the system that forces an auto scale out of 2 Node.js applications. You can see them coming up now. One's almost running, and there it goes. When it goes 3 of 3, it's running, and you'll see a response back to our user. So that's 20 concurrent users basically pounding on the server right now. There, the first one's up, and we get a response, and now we have our 2 Node.js also running. So subsequent requests are fine, right? They don't have to wait. But that cold start latency is the nature of a serverless application, because by default, serverless means you're not paying for servers, therefore there is no server. There was no node until we said, hey, I'd like to do something with Node, and Node came to life. So this is a feature of what's called Knative on top of Kubernetes. It basically is looking for inbound responses, or inbound requests, I should say, holding that load until they can start up the resources needed and letting the traffic flow through to the actual end pod. If I actually wait here long enough, which is about 65 to 70 seconds, you'll then see Kubernetes go, no one's using these things anymore, shut them down. Okay, but before it does that, let's look at its memory footprint. Noted. All right, and there they are. So you can see right there, so Node.js is 31 meg. My Java-based, CRUD-based application that talks to the database is 50 meg. They're almost the same size, and one's doing real work, and one's just hello world. Okay, and you can see there's one terminating now, so it's starting to get shut down now. And then in a few more seconds or so, you'll see the other one get shut down. So this concept of cold start latency is really important. While that's happening, I'm going to come over here and go to the Quarkus hello world, though. Let's get that one to burst out. Same concept here. You can kind of see, basically, it's going to come in, cause load. There's the 2 Quarkuses coming online. Again, you got to go for 3 of 3. This is based on Knative architecture. It has 2 sidecars. That's where the 3 of 3 comes from. But you can see my previous node is still up there. My Postgres is still up. And the API one is still up. And now Quarkus is up. It responds. And there we go. See, the second request is fine. The first request has to be held until appropriate resources are started. And let's look at that one from a Quarkus standpoint. And that one is 16 megs around. So smaller, half the size of Node.js as a Java application. Compiled to native, obviously. It's not using the JVM mode. I could use JVM. But you can kind of see there's my node getting cleaned up now. And if I wait about 60 more seconds or so, you'll see the Quarkus ones also get shut down. And so just the ones that have this 3 of 3 treatment are the Knative ones. The ones that have 1 and 1 are traditional Kubernetes deployments. That's kind of how you know. Okay? So if you actually think of it from a resource standpoint, kubectl get deployments is a traditional deployment in Kubernetes. kubectl get kservice is those special Knative services that have this special property of coming up and down. Okay? So this is why we worked on this kind of architecture. Hopefully that makes some sense, gives you a little feel for how it all works. Now we have a couple moments left. Maybe we can handle a few questions. Let's see here where the Slido thing went. Okay, we do have some questions. So are Quarkus apps restricted to just using those extension libraries? They're not restricted to that. If you want to bring your own library, we do recommend that you read the extension manual as well as so writing native application tips and extension manual. There may be some things you have to do here to get it to compile to native. Okay? JVM mode, probably no problem at all. You won't get the size and speed out of it. It'll still be kind of an old fat framework, if you will, but it'll still work. But in compile to native, it does need to be tweaked in some cases. In some cases, all you got to do is register for reflection. That's a simple annotation. That's it. That's all you might have to add. So just keep that in mind that some things may need to be, from a library standpoint, if you pick and choose libraries that you have internally, just read these 2 guides to figure out exactly what you would do there. Okay? Should expect a performance boost on startup also on every request. So you get a performance boost on startup, but not necessarily for every request, because once the application is running, it's just running in traditional application, right? It's just whatever your Java code will do, it's going to run at the same speed it does. Okay? I'm trying to think if there's any other. I can't think of anything else we've done in a special way to make, change the call stack or anything like that. There might be some fun stuff you could do there, though. There might be some pre-optimizations you could do there. I have to think about that. Does Quarkus reduce the general JVM overhead on a request? Not on a request. On the first request, yes, but not on subsequent requests once the JVM is started. Okay? Is GraalVM really production ready? The answer to that is no. All right? So Quarkus right now is just a few weeks old. GraalVM is still an RC release candidate. Okay? So it is not quite ready for production at this point. We use the community edition, by the way, the open source version, obviously. So it's still a 1.0 RC16, and Graal is a 0.13. Sorry, Quarkus is a 0.13. All right. Garbage collection. There is garbage collection running as a native executable, but it's not the same garbage collector as you're used to in the normal JVM mode. If you have an application that has a huge heap size and really needs one of those specialized garbage collectors, you won't find the special ones in native mode. Okay? Your native mode is really for those things like your serverless and microservice architecture, which are the more ephemeral applications that come and go. Right? If you live in a hardcore microservices or function world, right, in a Kubernetes world, those things are more ephemeral. They're not living for weeks at a time. Especially if you're practicing CI/CD, you might be turning over these microservices every day. And if you're in Amazon, you're turning them over every second. Right? They're deploying 2 deploys per second in some cases. So it really depends on how many deploys per week or per day you might be running. So you have to think about that. If it's a large heap situation, long-running process, you're probably better off with the JVM, letting it do its normal garbage collection. Compared to other JVM languages, distro kernel-specific native compilation. It is, I don't know about other JVM languages. I haven't tried it. Graal does support other JVM languages, but I've not personally tried them. You'll see that in the Graal documentation for Groovy and JavaScript, things like that. The JRuby guys are working on it, I know, because I just chatted with him. Charles Nutter works at Red Hat. But I don't know I have not tried any of them. And is it a distro kernel specific? No, it should work on any Linux that you want. It is Linux and Mac only right now. Windows is coming. All right, so it is Linux and Mac. In the case of Red Hat, Linux works for us, so we definitely look at it from that perspective. It is still just Java 8. Java 11 is coming really soon, so it's not quite here yet, but it is Java 8 today. And the kubectl load balancing sample, were all providers active? Yes. So that was true in that early example I showed you earlier. Where was it? Yeah, this guy over here. So this crazy thing I was showing earlier, they're all live and active, meaning if the transaction is routed that way, it's ready to receive the transaction. But the routing is based on the default load balancing algorithms that you've specified inside that code. So you basically decide who gets the most load. I want Amazon to get more load than Azure, or Azure to get more load than Google. So you can specify those prioritizations. It's just a simple configuration. And at the same time, you can specify not only do the prioritization, but it also looks at the real-time latency to determine prioritization. So for instance, my Google's sitting in India right now. So because that, it's so long, it has some additional latency. I put it in India for a reason, right, to just get it far away from me. And so therefore, it will prioritize the other data centers a little closer than, let's say, routing over there. So, but it's not really active-active or active-passive in that sense. It is active-active because it's just always on, and it's routing based on where it thinks it needs to go next, and based on also where outages are. And one thing that's also cool about this architecture is you can have dual paths. So right now, it is Amazon to me to Google, and me to Azure. But you could have like direct Amazon to Google, right? You can set up different paths for these transactions, and they'll flow that way. Again, this is all based on the Cupid dispatch router. Cupid dispatch router, that guy right there. That's where it is. And every one of the projects I have here are open source. We'll show you those if you guys want. How long does it take to compile to native binary? It depends on what it does, but you can kind of see, we talked through it. I don't know if you guys even noticed how long it took, but it might take a minute or two. It depends on your workstation. For instance, this is a 32 gig machine with 6 cores, so I have a lot of horsepower to throw at the native compilation. You will see that it will blow out of 2 gig. I've learned this the hard way this past weekend. I was like, it won't compile anymore, and I thought I did something wrong. Turns out I was running it against a 2 gig Docker daemon, not enough memory. And so 6 gig or more memory you need to have so it can burst out, do all that pre-processing logic that I mentioned, that code generation that I mentioned, and then get your native binary out the other end. So that one burned me recently. Can you do native compilation in a CI/CD pipeline? Certainly. It is a simple Maven command, right? If you look at it, it's just a simple Maven command. Let's see here. Where'd this one go? Right there. There it is. It is just a Maven profile. You just have to have enough resources to pull it off, and you have to have the Grail VM environment variable set. That's really it. Okay? It has to know where the Grail VM is. Okay, what else do we have here? Let me check it out here. Did I catch all these? Oh, and I know we're out of time. Many of my apps are Spring Boot and 11 Docker containers. Yeah, so right now we're not on 11 yet for all this technology. We're getting there soon, so 11 will be a problem. Spring Boot, of course, has its own framework architecture. Depending on what features of Spring Boot you use, those framework components may not have been migrated to this new small, fast world. So, some things have, but a lot of things have not. So it depends on what features of Spring Boot you took advantage of. It might be that you can't easily migrate that code base. You just have to kind of live in the Spring Boot world that you live in. Okay? Let's see. Can you learn the Java? Oh, yes. Out of memory fix, and I know we're out of time, but it's real straightforward. If I can show it to you real fast, if I can find it. 9 steps. It's in this set of demos. It's fairly easy once you know what it is. Okay, so here, this is where the problem will show up. I have 8U151. This is one that will blow up. If you actually get latest, they fixed it in 8U, whatever it is, 180 something, 190 something, just last week. But if you go to Java 11, it's fixed, because Java 11 fixes out of the box. If you still are on 851, you can unlock experimental options and use C group memory limit for heap. C group memory limit for heap. It's a mouthful to say, but basically those two right there will solve the problem. It'll basically say, I know you see all the memory on the machine, but it's not yours. Stop playing with it. And Java will respect that now with those two things. That's actually something one of the Red Hat people worked on. And then another fix for it is to simply just specify your heap size, knowing you'll stay well below the limit. Okay? So worst case is you're just going to set your heap size to stay well below the limit, and hopefully you stay below it. Just keep in mind that the JVM itself uses a lot of memory, so you're actually a little bit better with this option here, experimental options. And as I mentioned, the latest version up on Docker Hub has fixed it for OpenJDK. Okay, so those are your 3 different options there. JDK 11, unlock experimental options, set your heap. Okay? And then hopefully you won't see those out-of-memory kills anymore. We are out of time. I thank you so much for your time today. Hopefully you enjoyed the presentation. If you have more questions, feel free.